Hello students, welcome to the Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 1 of the topic electric charges and fields. So let us begin. First, we want to know that and which kind of what is the charges and which kind of charges could be there. Okay, so when we ask a question, what is charge? We came to the answer that it is the physical property of a matter that causes it to experience a force when close to the other electrically charged matter. Which kind of forces could it be? It could be a force of attraction or it could be a force of repulsion. This force is due to the property that we known as the charge. Okay, so in class 10th also you have understood that force of attraction would be there, force of repulsion would be there. You are well aware that when two charges are of opposite nature, one is positive, another is the negative. They are having a force of attraction, and when two charges are of same polarity, this is positive, they are force of repulsion. So this is what we know as the what is the charges. And when we know the what is the charges, we are about to apply a charges to a body. So let us suppose we have taken one sphere, as you can show in the figure. So this sphere is given a charge, but one very surprising that these charges are not in a motion, but they are the stationary. What we call as they are the steady charges. So when they are steady charges and they are not moving, so study of this charges is called the static electricity or electrostatics. So when charges are at rest, they are not moving. Study of these charges are the electrostatics or static electricity. Okay, so then what would be happen when charges are moving? So let look at this copper wire. Hannah, you might have seen this at your home also. This copper wire is having a negative terminal. This is having a positive terminal, and this electrons are moving from, let us suppose, say positive terminal to the negative terminal in the wire. So these charges are in motion. So study of these charges while they are moving is called dynamics or current electricity. So basically we have two kind of situation. One is the electrostatics. What is that? So when the charges are at stationary or at rest, they are studied under the concept of electrostatics. While charges are in motion, when they are moving in a wire from one place to another, they are studied under the unit of current electricity. In standard 12, we have unit number 1 and 2 as electrostats. And in standard 12, unit number 3, that is current electricity. That is the for first and second unit, we are studying the charges when they are at rest, they are not moving. In standard 3, in class 3, unit 3, we are going to study them while they are moving. They are the current electricity. So let us begin a certain more detail of the concept of the charge. Two kind of charges would be there. You know that. One is the positive charge, another is the negative charge. Which one is said to be a positive charge? So by conventional, we have decided that proton is said to have a positive charge and electron is said to have a negative charge. So charge of a proton would be considered as a positive, charge of an electron would be considered as a negative. And magnitude of a positive or negative, mind well, I am saying about the magnitude. Yes, I am talking about the value only. Magnitude of a positive or negative charge is 1.6 into 10 to the power minus 19 coulomb. Please do remember this. One very interesting thing is a charge is a scalar quantity. So while we are going to adding it up, we do not need to bother about the direction because it is a scalar and they can be added with the help of scalar addition only. So we are going forward, and we know this positive charge, negative charge. Charge of proton is positive, charge of electron is negative, and magnitude of one charge is 1.6 into 10 to the power minus 9. Yes. So let's move to the basic properties of the electric charge. Which are they? So first is the additivity of a charge. What is that? So let us suppose if I say this is my system and it is having a charge Q1, it is having a charge Q2, it is having a charge Q3. Then total charge on this system would be equals to Q1 plus Q2 plus Q3 and onwards. So we need to just add them algebraically because these are the scalar product. These are the scalar quantity that we have defined in previous slides. So charges having a magnitude only, they are not having a direction. So I guess you might compare it with the masses. Even masses are the inherent property. They are the internal property of a matter. They are even a scalar quantity. So even masses are added directly, algebraically. So you might be comparing charge with the mass. So charge has a magnitude, no direction, are similar to the mass. But there is a one bigger difference between mass and charge is there. Think what it would be. Think for a little. Can you get it? Let me show you. Mass of a body is always positive. Mass cannot be a negative. We cannot have a body like the mass of this body is minus 4 kg. This is not possible. Not at all. But charge can be either positive or negative. We can say this that this body is having a charge of plus 4 coulomb and this body is having a charge of minus 4 coulomb. We can say this. This is absolutely correct. So when we add these charges, we need to take consideration of sign as well, which are the positive, which are the negative. So let us say for an example, a certain system is there which are having this many charges, 1, 2, 3, 4, and 5 in some arbitrary unit. Let us say suppose in certain units. And then total charge of this system would be equals to, we are just need to add this plus 1, plus 2, plus 3, plus 4, plus 5. Do it. 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15. So total charge would be 15 in that system. I hope this might clear. So we can directly add the charges. Next and very important property of a charge, that is a quantization of a charge. So what quantization of charge is? We simply say that whatever the total charge of the system that I denote as a Q would be equals to integral multiple of single quanta of a charge where n is the integral multiple only. I hope you might know what is integral multiple. It can contain complete number only. Complete number means it could be having n is equals to 1, 2, 3, 4, and onwards. So it that we call as an integral multiple. So this basic unit of charge is the charge that an electron or proton can carry. This is equals to n. So by convention, the charge of an electron is taken as a negative, and by convention, charge of a proton is taken as a positive. Okay. So how quantization of charge is when and when we are going to cover q is equals to plus or minus n where n is the integral multiple where n equals to n could be 1, 2, 3, 4, and onwards. Yes. So let us suppose this is one system and this system is having a charge of 3.2 into 10 to the power minus of 19 coulomb. So would it be possible? How could I check it? So I know this q is equals to ne. What is the charge of this system? This is 3.2 into 10 to the power minus 19. This is n. What would be the value of e? Try to remember. This is 1.6 into 10 to the power minus of 19. So this comes n equals to 2. S2 is the integral multiple number and this could be the unit. So I hope now quantization of charge is clear to you. What is the quantization of charges? And every system can have total amount of charge that is integral multiple that we call as an integral multiple of single quanta of charge. Single quanta of a charge is having a value of 1.6 into 10 to the power minus 19 and could have a value which could be an integral multiple, which can be having 1, 2, 3, 4, 5, 6, 7, and onwards. Anything could it be there. But it could not have a value like n. equals to 3 by 2. No, this is not possible because this is 1.5 and could not have a 5 by 2 because this is again a 2.5. So, but this could be having n equals to 6 by 2 because this is 3. So, do not tempt it. So, n can be having a 3, but n cannot be having a 2.5 and could not be having a 1.5 and something like that. So please remember this. Okay. Next, moving further, what is the charge and its units? So in the international system of units that we learn as an SI system, you might remember that in class 11, second unit, we have introduced this SI system, a unit of charge that we call as a coulomb and denoted by a symbol C. So when and when capital C would be there, they are representing a charge. They are representing a charge. Please remember. Yes. Now what is charge or how this unit came? So what we know is I is equals to Q by T. Did you remember this? Where do you learn this? In class 10. Please do remember I is equals to Q by T. So if I replace this, Q is equals to I multiplied by T. So if I say a current of 1 ampere, if I say current of a 1 ampere is passed through a 1 second, then the charge would be equals to 1 coulomb. So in terms of this definition, we can say 1 coulomb is the charge flowing through a wire. It is 1 ampere for a 1 second. So we understand that this is the value of an E, single quanta charge. This is 1.602 into 10 to the power minus of 19 coulomb. So if I want to calculate how many charges that are being passed, how many charges that are being passed, or what are the number of charges, so I can do this. Q is equals to n into E. From this I can write n is equals to Q by E. So Q is the one coulomb of charge, let me take it, and E is the 1.602 into 10 to the power minus 19. You would be surprised that comes to 6 into 10 to the power 18. So there are about 6 into 10 to the power 18 electrons in a charge of 1 coulomb. Basically 1 coulomb charge. Basically a 1 coulomb charge is very a bigger unit. So normally we are going to use millicoulomb, that is milli 10 to the power minus 3, or we are going to use a microcoulomb, that is a 10 to the power minus 6 coulomb. But up till now we have learned the additivity property of charge. We have learned about the quantization of charge. We know the unit of a charge and so on. I hope this might clear. Next, moving to the next. So, how it could be, how I can calculate the total amount of charge on the system. Let us say this is system. This is plus 4 coulomb. This is minus 2 coulomb. So then I say plus 4 minus 2. This comes to and plus 2 coulomb. This is additivity. Same way. If I say this is N1 amount of positive charge is there. So it is N1 into A. And N2 amount of negative charge is there, negative. So total charge Q would be equals to N1E minus of N2E. I have written a minus here because it is a charge of electrode. So that should be is equals to N1 minus N2 into E. Is it positive? Yes. I have considered N1 as a proton and N2 as an electron. N1 as an proton and N2 as an electron. So N1 is considered as a positive and N2 is considered as a negative. Okay. So next, properties of electric charge is very interesting. We say that electric charge is invariant as it does not depend on the motion of the charge body or the observer. So it means Q at rest and Q in motion both would be the same. But why do we say this? Because did you know that mass changes with the help of motion or mass remains the same? Think, rethink. What was your answer? What I can guess is your answer is ki no sir, mass never changes. Mass remains the same. If a car is moving, its mass does not changes. Yes, it is absolutely this. When car is moving, it is not Its mass not changes. But a certain scientist would there who has given a one very interesting relation. Please note that he has said this would be the relation m is equals to m naught upon 1 minus v square by c square. M naught is the raised mass. M naught is the raised mass. Matlab mass of an object when it is at rest. V is the velocity of an object, or you can say speed of an object. And C, you might know it is a speed of a light. This is speed of light. So they said when an object travels approximately equals to the speed of light, this m changes. Surprisingly, but this is true. So when we considered a charge, we said a charge is invariant in nature, but mass is variant because it do changes. It changes with its speed. So remember this: charge does not change, mass changes. Okay, one interesting question. Do you know one quantity would be there which we call as a specific mass or specific charge? This is Q by M. This is specific charge. This is specific charge. Now one question for you. Just do think on this. That we know that charge does not change with the motion. Mass changes with the motion. But do specific charge changes? Just think over it. We will get back to this in next class. You are having a time up till next class. So what you are going to do is you just consider that charge does not changes that we know. Mass is going to change even that we know. So what happened to the specific charge? Does specific charge, which means it is a ratio of Q to the M, does it changes? If yes, what would happen if speed increases? What would happen if speed decreases? Think over it. Very interesting. So let us move to the next property of an electric charge. When and when we say that if a charge is distributed on a surface, what we understood by this? So let us suppose we have taken a two different shapes of the conductor. One is the spherical conductor. One what we have considered is the spherical conductor, and another what we have considered. Another what we have considered. One we have considered that is of spherical conductor, and another what we have considered is the pearl-shaped conductor. Yes, what is prime difference between these two? This is a sphere having a no edges. It's a complete circle. And this is a object having a different sides of edges. Look at this. Both are having different radius. So it you might observe that in a spherical conductor, charge on surface is equally distributed. It means if you consider these points A, B, C, D, all locations having an equal amount of charge, or you can say approximately equal amount of charge. But look at the second diagram, that is the pearl shaped conductor. Look at this position A, this is position B. At position A, you might observe that there are less number of charges and position B having the more number of charges. So we from a diagram we can come to the conclusion that at sharp edges charges would be higher. Do remember this, at sharp edges charges would be higher. In unit 2, we will derive this. Do remember, but at this point of time you just remember this, that at sharp edges charges would be higher, and at flat surfaces charges would be a lesser. So a very interesting property, and that needs to be remembered by you guys. So next let us come to the next property, that is the conservation of charge. Now, very first thing, what do you understand by conservation? What do you think by it? What is conservation and what does it mean, conservation? So when and when we considered a conservation, when and when we come to know that it is a conserved, what it comes to your mind? What I consider is whatever the quantity was there before certain time, that should be the quantity next amount of time. That I understand by a conservation. So quantity before certain situation would be same as the quantities after certain situation. That I understand by the conservation. Now, how can I say this for the conservation? Let's begin. So, let us suppose this is my system. So, and this is a body having a sphere A having a Q1 amount of charge, a body having a B having a Q2 amount of charge. So, total amount of charge that my system is having, total amount of charge that my system is having is Q1 plus Q2. Now, what I did is I make them in a contact. Body A and body B now in a contact. When body A and B are in a contact, this is the final situation. Can you observe anything? Just think, reimagine the diagram. Look at again, one more time. You might observe that there are charges distributions. Charges have been distributed themselves between A and B, but total amount of charges even after their contact is Q1 plus Q2. So when and when we consider the charges are conserved, look at this. Before contact, this is the after contact situation. This is the before contact. Before contact, what would be the total amount of charges that your system possesses? It is a Q1 plus Q2. Yes, correct. Yes. What would be the total amount of charges after contact? It is a Q1 plus Q2 again. So before contact, total amount of charges that system A plus system B, that is our whole system A and B, while adding up make our system. So alone A is not a system, alone B is not a system. A plus B is our system. So total charges before contact is Q1 plus Q2 and total charges after contact is Q1 plus Q2. So for an isolated system, this is very much required a word, isolated, which means my system does not have any relation with external world. So for an isolated system, net electric charge always remains constant. So this is clear, is it? Yes. Let's move on to the very next topic and very interesting. That is the electrification. How it done? Did you try it before as well? So, based on electrical properties, we define our objects in three terms. One is the conductors, another is the insulators, and the next is the semiconductors. We are coming to the electrification, but before this, we need to understand this. So, let's come started with the conductors, insulators, and semiconductors, and then switch to the electrification. So we can divide this three. We can divide properties, or we can divide metals, or we can divide objects in this three category. Basically, one is the conductor, another is the insulators, and another is the semiconductors. In previous classes, you might have studied about this. What are the conductors? When we say conductors, when we say conductors, we say that when and when we consider a conductor, we say it is a material which through which charges flow easily. Okay, which materials can be considered as in conductors? We know that most metals, approximately 90 percentage of metals, are very good conductors. So charges can flow through these metals very easily, and approximately 100% charges can flow through the conductor. So these are the conductors. Next, which are the insulators? It is exactly the reverse property of a conductor. We say that insulator is a material through which charges flow poorly. But when we say poorly, even we are talking about the practical situation. If I think an ideal situation, they are not going to pass at all. So we say when charges are not passes through a material, they are the insulators. Okay. What are the examples? What are the examples for the insulators? We'll say silk, we can say cotton threads, a rubber, plastics, all are the good insulators. Remember this. And one more, semiconductor. What is it? Have you studied it? Semiconductors. In chemistry, you might have studied this semiconductor. Try to remember. You will recall it. Yes. What we say is about semiconductors, we can say that they are having an electrical properties that lies in between conductors and insulators. That means they can conduct poorly as compared to the conductor, but they can conduct very fairly as compared to the insulators. Which are they? Germanium, silicon, gallium, arsenic, etc. We are having a complete unit based on semiconductor only. It is the last second unit of your class 12 and very important for NEET as well as JEE for both the purposes. So we will come to that at that point of time, but at this point of time, you just remember that they are the semiconductors which are having a property between metals and non-metals, or we can say between the conductors and insulators. So let's move to the next. Now we are back to the electrification, how to charge a body. This is basically electrification. These are the methods of electrification. That's what we know is the how to charge a body. How to charge a body. That means how we can provide a charge to a body. We have approximately three methods: charging by friction, charging by induction, charging by conduction. So, how many of you know that what is charging by friction? Do you remember in class 7th and class 8th, certain experiments were there where you are going to charge a certain object by a friction method? Can you recall it? Look at this. So, first method is method of charging, and we are going to use a charging by the friction. What we are going to do is we are going to take a glass rod and we are going to take a silk cloth. When we are going to rub this glass rod and silk cloth, after certain time of rubbing with each other, glass rod becomes positively charged body and silk cloth becomes negatively charged body. Okay. Now one more question might arises. What is positively charged body and what is negatively charged body? The body which loses the electrons is positively charged body. The body which loses the electrons is positively charged body. And the body which gains electrons, that you understand, is negatively charged body. So the body which receives an electron is negatively charged. The body which loses or which donates the electron is positively charged body. So glass rod becomes positively charged body and silk cloth becomes the negatively charged body. There are other examples too. Do you remember how charging by friction works? There are other examples too. Did you try it? That let us take a one scale made by a plastic scale size would be a 1/5. Rub with your hair. Uh, ensure that your hair is having a oil. Rub the scale with your hair. Now take one paper, convert it into the beads of paper. Just tear it and tear it into small pieces. Now try to attract that beads of paper with the help of the scale. It might work. How this happens? This is charging by friction only. When you rub a scale with your hair, you are about to charge a scale, and the same thing happens. Okay, one more example could be there. When you when you beat a plastic chair, let us suppose by a hanky, then at certain point of time you can feel a spark in that plastic chair. What is that? You are charging that plastic chair with the help of hanky, so that charges do arise. So these are the various examples of methods of charging. Do remember, and very interesting. Next method of charging is charging by induction. For your remembering purpose, you can understand these are the wireless charging. Wireless you very well know. Yes. So what happened? Let us suppose this is positively charged body and this is uncharged body. This is uncharged body. So what happens when this body and this body came closer to each other? So look at this. These are the positive charges. So due to positive charges on one side, it induces a opposite nature of charges on the other side. So here are the positive charges. So this body is having a negative charges. This is charging by induction. Even reverse is true. Say, let us suppose these are the positive charges, these are the negative charges, and let us suppose this is the uncharged body. So what happens? This will be having a positive charge at this side and negative charges on this side. This is too possible. This is charging by induction. Next, one more method that we left is the charging by conduction. This is wired charging. So what we are going to do is, this is one object, this is second object. When I want to charge one body by another, I just connect it by a conducting wire. I just connect it by a conducting wire. When I connect this two body, charges do transfer from one body to another. And when the charges are transferred from one body to another, this is what we call as in charging by conduction. So, is it clear? Yes, very good. So now quickly revise this. What we have learned up till now. We know what is charge, what kind of charges would be there, what is charge of proton, what is charge of electron, what is the unit of a charge, what are the properties of the charges, and different ways to charge a body, to electrify a body. I hope this might clear. Thank you so much for today. Thank you and have a good day.